In this video, we're going to talk about scripting. Scripting is a macro or a way to add advanced features into a particular cabinet part. The script that we're going to take a look at is a script that adds 2 extra holes for a hinge plate when a cabinet side exceeds a certain height. The script that we're using here is center hinge holes, and it is a script that creates these 2 holes right here when a cabinet exceeds a certain height. To get started with this, we're going to have this screen open so we can see what these settings are. We'll bounce back and forth from here. We are also opening up a file that is a PDF that's called user scripts. This is a file that describes a way to extract the settings from CabinetPartsPro so we could use those in the script. We're also needing to open up the center hinge holes. This is the script itself, the VBS file. It's Visual Basic Scripts. All these files are located in the C drive, Program Data, CabinetPartsPro, the 1.0s, and then in the script folder. Now we're going to take a look at that file. I'm viewing the script file, the center hinge holes VBS file, in a program called Notepad++. This is really nothing more than just a basic notepad, only it adds some color coding for the programming aspects of it to help clearly see what is going on. So we're going to start really right in the middle of this script here, and then we'll expand outwards to hopefully get a better understanding of what is happening in the script. So right here on line 38 is where we have the DXF function that is creating a circle. So it's DXF.circle, and it is placing a circle at these XYZ values with a layer name. So XYZ, we have X, Y, and Z. X is getting its hole placement value here, and we get hard code numbers in here as well, in here, and then the Z. Well, I already see that we have somewhat of a problem here with the Z because we do not want that to be -1 deep. We will want that to be a value within the settings, so we will get that corrected as we go through this process. Then the radius is the hinge holes dot diameter. This diameter is being extracted from the settings of CabinetPartsPro with the diameter, which is set at 197. And I know it is hinge holes dot diameter by taking a look at that PDF file that we opened up, going down to hinge holes. Hinge holes is the primary heading. Then it's going to be dot, layer name, space, inset, up or down, up, bottom, top, diameter. So we have hinge holes and then the diameter. But we're also going to need this depth, and that is how we are going to correct the -1 setting within that script. So I just double clicked on the depth, and I'm doing a Control-C to copy that just to make sure I get exact spelling and everything correct. And I'm going to modify this value right here. I still need that -1 because this setting, as it is extracted, is a positive number, but we need to have it as a negative number to be able to cut down into it. So multiplying any number by a -1 is going to give us a negative value. So -1, and I'm going to go times depth. But depth alone is not doing anything. A depth of what? Depth of hinge holes. So we're going to copy that. So it is hinge holes.depth is now going to give us the correct depth based on the settings within CabinetPartsPro. So we could take a look at the hinge inset. The inset, again, is getting hinge holes inset, again, being extracted out from CabinetPartsPro. We have a little bit of a if condition here. I'm going to set that aside for right now. We're not going to pay too much attention to that as we work out. So right now, these two sections here are giving us those two holes. The X value is coming from the cab center, which is cab center is really nothing more than a made up word. I made that up, which is corresponding to the half of the height of the cabinet. And I could see that by getting this PI, which is the part size of the right side of the X value. So that is essentially the height of that cabinet, and I'm dividing that by 2. So if that cabinet was entered in at 30 inches, the cabinet center is going to be equal to 15. Then we are going to subtract the hole spacing. This hole spacing, again, up above, we have a variable. Again, this variable is a made-up word. It could be whatever you would like it to be. And it is going to be equated to hinge holes, the space, divided by 2. So the setting that we have in CabinetPartsPro by default is 1.26. So it is going to be equal to half of that. So when we come down to the placement of the X value, we are saying we want that hole to be at cab center, which is that 15, half of 30, and we're going to subtract half of that spacing, which is that hole space. And then the same thing, or the opposite, for the second hole. Instead of subtracting, we're adding to it. So that's giving us the 2 holes in the center of that cabinet. Now, I am saying that at 15, now that doesn't necessarily mean that we are going to drop down into any of these, because we have a if statement here. This if statement is a condition statement that is saying if the right side dot X value is greater than max height, then let's do what's inside of this if to this end if. And when we're programming, notice how things right here are indented. So we see everything within that if block between the if and the end if is indented, so we can clearly see what is happening within that section of code. So again, coming into here, it is only going to fall into this section and create those holes if this condition is met. So max height is also a variable. Again, it could be named whatever you would like it to be, as long as it's consistently all the way through. Max height currently is set to be 36 inches. So any cabinet that is above 36 is going to get the second set of holes in the center of the cabinet. Expanding out a little bit farther, we have another condition statement, and that is right here. So this is the full block of code that we're looking at. So it is only going to even check to see if the max height is met if the part name is a variable that is pulled in from CabinetPartsPro when we calculate nest. So part name is going to be equal to the part name. So we only want to fall within this condition if the part name is a right side or a left side. Taking up a little bit farther, we see that we have a couple other condition statements here. And within the placement of the holes, we may need to shift up or down depending on if there is a toe kick in place or not. So what we are saying here is the offset bottom, right here, offset bottom is equal to 0. If the toe kick notch dot cut equals true, that means if we have CabinetPartsPro's checkbox to say, let's cut a toe kick notch, that is going to be true. So if that is true, offset set bottom is going to be equal to the height of the toe kick. We might want to use that to be added into the X value to shift those holes up off of the cabinet just a little bit, to allow for the holes, or to have it centered within the top of the toe kick notch to the top of the cabinet. We're currently not using that in this script. As we see, it is doing nothing more than just giving it a value, but offset bottom is not being used down below in this script that I currently have. I am going to continue to make some modifications to this script, so by the time you actually view this script, you may see this offset bottom being used within the logic of the placement of those holes. So that is really the basics of this script. Hopefully I've made it clear enough. The word programming sometimes scares people, but if you go through and study the logic and understand the logic one step at a time, it's not as difficult as you may think it to be.